Alright everybody, so from now on we are gonna follow the lessons from here, as you can imagine, because of the reasons. So if you remember, we had lesson 9-1 and lesson 9-2 so far when we were back at school like 3 weeks ago. So we are gonna follow from the lesson 9-3. If you remember, the lesson 9-1 and 9-2, that was about more algebraic way to solve rational functions, like how to add, subtract is the lesson 1, and how to multiply and divide the given the rational fractions was the second lesson. So we had AMI days about these. I hope you are doing fine on them. Still, if you have questions, let me know. Just send me the assignment number and the assignment question so we can work on it. So from now on we are going to continue with the lesson 3. So this is how we will do. Every week we will have 1 or 2 lessons according to the length of the lesson. So this week we will have only one, that's lesson 9-3. Since it's a long and a little bit complex one, we will work on this one this week. So every week I will send you 1 or 2 lessons through this way on YouTube that you will find the lesson. On Tuesdays and Thursdays I will assign you for Tuesdays and Thursdays the Alex assignment related to these topics that we have, 9-3 or the other lesson that we will maybe another time. So, and we will also work on the questions on the book. So basically 2 things. One is the book that we will follow, the lecture part as we do in class, and we will solve some question exercises. And the second one is the Alex that we will still follow. So it's just like how we do in school. It's a little bit like distance. So what I can suggest you is that before that, of course, like you know how I will solve the questions. So it's just like in the book, but consider it's not on the whiteboard. It's on this program, the Mimeopad. So I will teach you the things here slowly as much as possible. So I suggest you to stop the video and watch it. When it is necessary, rewatch it. Just like take 5-10 seconds before and do it again. Still, if you have questions, just send it through the Google Classroom as you normally do. I will try to return them as fast as possible. So when I'm doing that, just like in the school, you are gonna write them on the related pages. Like each question, I just copy it here on my Mimeopad. I will solve them here and you will copy the answers. You can fill the gaps over there, but I will follow a little bit different way because I didn't copy everything on the book. I just copied the questions. So you can find the missing gaps, or this is better, write the things that I'm writing here on the screen on the side of the question. When after the class you know that you're gonna work on it right by yourself, so maybe at that time you can fill the gaps. So this is gonna be your second study basically, and it's gonna help you. Then you can start to solve the exercise questions at the end of the lecture. Alright, other than this, since you know this is something new, we are very beginner level of this one, so not everyone is so well on this, including me. I believe it's gonna be much better once we get used to it, like this online teaching. But what I suggest you to is that you should be responsible of your own learning, which means yes, we are helping you here, the teachers, through these online platforms, but still this is your responsibility. So one thing that you should follow all the time is be responsible of your own learning. Just educate yourself with these videos, Khan Academy, Alex, the book, get some help, ask questions. So this is gonna actually improve some of your skills, like that you're on top of it, you're more active in this case, unlike in school, which is good at some point. Alright, so if you're good, let's get started after this 5-minute preaching and how we will do the classes. One more time, I will upload 1 or 2 videos of lessons each week that you will watch, fill the gaps on the book and study that and do the questions at the end of the lecture part. Of course, we have Alex too. Okay, so lesson 9-3 is basically on page 467. So you should open the page 467 and you're gonna see this whole thing right over there. So let's see what we are going to do in this lesson. As I said at the beginning, this is the unit rational functions. We did the algebraic stuff, how to add, multiply, divide, all those kind of things in the first two lessons, and this lesson is about new terms like asymptotes, vertical, horizontal asymptotes, how to graph the given rational function, how do you find the domain and range, these kind of things. So it's more analytical in this case. Alright, so let's start with the first thing. As you can see here, we have the 1 over x. F of x is equal to 1 over x is the parent function of this given rational functions. This is the rational function, the parent one. By the way, don't mind my handwriting. It's gonna be hard to write on this one, but I will get used to it. It will be much better in the next lessons. So we can assume that it's a hyperbola type, which is good because hyperbolas are like these butterflies, like this one here. So basically, if you graph 1 over x on your calculator, looks like it's gonna look like this one. We have a right branch and a left branch here. Looks like domain and range is all non-real zero numbers. What's that mean? So if you look at the domain here one more time, you know domain is about the x-axis, right? And the branches cover entire x-axis here, here, and here. But looks like we don't have a zero here, because if you look at this branch, it goes to the x-axis all the time but never crosses, and same thing here, goes to the y-axis but never crosses. Same on the right branch too. So I can tell this function never touches zero on x-axis. So that means all real numbers, yes, we can put like any number here, all real numbers except 0. Because you cannot put a 0 in this one. Or if you consider a range based on the graph of 1 over x, same thing here, we can have all the numbers on this line, the y-axis belongs to the range, except the 0 itself. So same thing that I can say here, a, r, and remember what's that mean? Except 0. Alright? So the other way to say it's all non-zero real numbers. Non-zero means it's something other than 0, as you know. So anything that you can put like here, like negative infinity to negative 1, 1 to infinity, even the decimals between negative 1 and 1 are fine here. And you will also get answers, and these answers will be anything except 0. So those are domain and range. Asymptotes. We will talk about deeply in this lesson about the asymptotes. F of x is equal to 0. The other way to say is that y is equal to 0 here. You can tell that, right, from the exponential logarithmic functions. In exponential functions we had only the horizontal asymptotes, whereas in logarithmics, the previous two units, we have the logarithmics, the vertical asymptotes here, right? In rational function we will have two at the same time, and most of the time you will see these two together. There will be the horizontal and the vertical asymptotes most of the time together. We will see this deeply again, but here we can tell x is equal to y is equal to 0 is the horizontal asymptote, this line, the x-axis basically, and the y-axis, the other way to say x is equal to 0 will be the vertical asymptote. So you can tell asymptotes are associated with domain and range. Yes, we can say that. Alright, so this is what we will do. So let's see our first example. First example is that determine the excluded value of x for each function. You may remember this one from the AMID work for last week. That's true. Excluded means what makes it undefined. What makes it undefined? Right? So basically what makes this thing undefined is the denominator, right? So you will check the denominator, you will get the denominator equal to 0. Since we have only x for the denominator, x cannot be equal to 0. So that's the excluded value. You can associate this with the asymptote, vertical, horizontal, domain and range thing too, but so far we're just thinking what makes it impossible. That's 0 itself. Okay. Second question, like still, this is question 1, guys, on page 467 again, at the bottom. We did 1a. We said the function is undefined for x is equal to 0, or you can say x is other than 0. So the question B. So looks like we have another graph, a rational function, 2 over x minus 7. So as you can tell, x minus 7 is going to be equal to 0. If you solve it as you know how to do, x is equal to 7 makes it undefined. So basically the excluded number is going to be 7 here. If you're going to go further, this is the way to say all real numbers is going to be the domain except number 7. You can plug in a number here that will give you an answer, but 7 itself will make it undefined because 2 over 0 is something not cool. Okay, 1c, let's see what the 1c says. Same thing here, you know, if you are looking for what is the excluded value, 3x plus 4 is 0, you take the 4 to the other side, basically you subtract 4 from both sides, divide by 3 as it is instructed over there. So you got the negative 4 over 3 is not part of the domain, so excluded number. This is the excluded number from domain. All other numbers are fine. Negative infinity to positive infinity, all of them are cool. Okay. Alright, so this is example 1. Alright. In example 2, we are going to do cooler stuff, which is more advanced, of course. We are isolating right now. So it says graph the given rational function. By the way, the other way to say a rational function is this reciprocal function. If you see me, I mostly say rational function, which is I prefer better, but reciprocal is the same thing, by the way. It says graph the given function by finding the vertical asymptote, horizontal asymptote, x-intercept, y-intercept, and just graph it. Alright. So before we do that, identify key features. Yes, we mostly show the reciprocal function in this way. F of x is the reciprocal function, n is the number over b of x, which is the denominator plus k. So here's the deal. If we want to graph a rational function, a reciprocal function, we are going to look at two things: horizontal asymptote and vertical asymptote. So this is important, guys. This is how we can find the horizontal asymptote. If you are looking for what is the horizontal asymptote, that's very easy. That's the k. So you will say y is equal to k. Maybe I should write that way. Y is equal to k is the horizontal asymptote. Vertical asymptote is basically this. What makes the denominator equal to 0? Oops, messed up everything. What makes the denominator, which is here in this case b of x, equal to 0 is going to be the vertical asymptote. So what's that mean? One more time. If we are going to graph a rational function, we need to know what are the horizontal and the vertical asymptotes. And if you're looking for the horizontal asymptote, this is going to tell you for that. And if you're looking for the vertical asymptote, this is going to tell you what's the vertical asymptote. So two things. The denominator is the vertical asymptote, and the number here, plus or minus, that's important, is the horizontal asymptote. Alright, so when we go to this question, I can tell the horizontal asymptote is just 2, right? Because look at that, what I said here, y is equal to k. So in this case, it is just 2, is the horizontal asymptote. But if you're looking for the vertical asymptote, the VER, I say, you are gonna check this whole thing, 2x minus 5. So 2x minus 5 should be equal to 0. That's the case. If you do the math, you add the 5 to both sides and divide by 2, you are gonna for sure get x is equal to 5 over 2. The basic math that I skipped. Add 5, divide by 2. So we have two things. Horizontal asymptote in this question is that we show it with y. Make sure you always show it with the correct letter. Horizontal asymptote is y. Vertical asymptote is just x. So that's y is equal to 2 and x is equal to 5 over 2 here. Now, once you got them, it's easy. Just like what we do, we'll draw the xy plane as usual and put these numbers here. Let's start with horizontal asymptote. 2, right? So we will have a horizontal asymptote here. So assume that is a 2 here that's passing through right here. Y is equal to 2 and x is equal to 5 over 2. That's a 2.5, right? So I can tell it is somewhere here. Since it is vertical, it's gonna be a line here. Oops, it's a little bit bad line. So it's gonna be here. X is equal to 5 over 2. There we go. So these are our boundaries. Our function, you remember the very first one, the 1 over x, it was like a butterfly. So it's gonna be like that. So this is what we have so far, right? So if you look at the next page, the 469, we are gonna find x and y intercepts. So first, if you're graphing a rational function, you need to determine what are the horizontal and the vertical asymptotes. That's the important one. Then plot some other points. If you prefer to find x and y intercepts, that's better. But any other point that you can find is good. So if you look at the page 468, there's a table on the very bottom. So you just fill it with using a calculator. And those are numbers. That's also even fine. But if you find x and y intercepts, instead of like making table all the time, that will be cool. How? So let's start with the x-intercept. I will just change the color. Remember, if you are looking for x-intercepts, that means y is gonna be equal to 0. So just like in any kind of function, if you're looking for an x-intercept, quadratic, logarithmic, exponential, any kind, that you will just substitute the y equal to 0. Y with 0 if you are looking for x-intercept. So this is our function. So you know this means also y, right? This thing that you see here is y. So I will just change it with a 0. It's just equal to 1 over 2x minus 5 plus 2, right? That's the thing. Looks like we have to solve this. How? Subtract a 2, right, from both sides. If you do that, you got a negative 2. I subtracted 2 from both sides, guys. We got a 1 over 2x minus 5. The 2 is gone because I subtracted 2. I'm not writing 2 here because I don't have enough space. I don't want to make it confusing more. So that's why. So I just subtracted 2. You already know it. You guys are smart. And how we do this? Maybe basically just like in the way that the book says, consider this a fraction, negative 2 over 1. Just do the cross multiplication. I will multiply negative 2 by 2x. That's a negative 4x. And negative 2 times negative 5 is positive 10. And if you do the 1 with the other one, that gives you just a 1, right? And if you solve it, subtract a 10 from both sides, divide both sides by negative 4, you will just get a 9 over 4, right? This is going to be our x-intercept. So it's a good point to find out where is the x-intercept here. You know, 9 over 4 is almost, not almost, it's exactly 2.25 if you do the calculator thing. And I can tell it's going to be, you know how this is a 2.5, right? So I can tell the x-intercept is 2.25, which is slightly less than the vertical asymptote's number. That's 2.5 here. So we got that. Let's find the y-intercept too. I wish I had enough space, but maybe I can just create a new page and find it over there. So So next page. So the question was that now we are looking for the y-intercept. I'll change the color. Y-intercept. Remember the y-intercept this time means x will be substituted with 0. Remember the function we are given here, 1 over 2x minus 5. Right? This was basically the function of plus 2. Of course, we have a plus 2 here. This is the function itself. It says g of x, but I say y. Whenever you say it says g of x or f of x, you can say it is y as well. Alright, so we are substituting x with 0, which is easier here in this case, because I will just substitute the x with 0 and do the basic math and find the answer here. Right, taking this whole stuff here. This is a negative 1 over 5 on bottom, because this thing is gone. Negative 1 over 5 plus 2. If we want to see what's in decimal, I can tell you that's actually 1.8. So this is gonna be our y-intercept. Let's take this one to the previous page. We got the y-intercept as 1.8. So 1.8 is a number slightly less than 2, right? So 2 is here, right here. The horizontal asymptote, and the 1.8 is here, is our y-intercept. So basically, you know how we will have two branches, right? One of them will be passing through here. It has to cover both, so it's gonna become along the 2 and goes like this. Well, once you find one of them, the other one is easy. It will be right across it. You know how we have 4 regions here, 1, 2, 3, 4. It's in the basically third region, and the other branch will be, of course, will be here. You can verify it is here by basically plugging some other numbers, just like the table suggests on page 468 on the bottom. Plug some numbers more than 2.5, you will see some numbers exactly on this curve. But again, as long as you find x and y intercept, it will tell you something. So here it will be passing here and here. So this is gonna be our how the graph will look like. Alright, so one more time on example 2. Basically, if you need the graph, find the x and find the horizontal and the vertical asymptotes first. Horizontal asymptote is this number. Vertical asymptote is what makes the denominator equal to 0. So we got them 2 and 2.5. We put them here, and we also found the x and y intercepts and put the graph, and it's just a butterfly, one here and here, the branches, and that will be the graph itself. All right. So, example 3. Example 3 is now more on like a, when we solve a mathematical question, we move to a real life situation, right? There is a physics question here. I can tell you if you like, oh, physics, right? It's hard. Yeah, it is, but don't worry about it. We're just gonna look at the math part of it. So IVR, right? So not that hard. If you read the question, V stands for the voltage, the potential difference, the other way to say that 110 is in the given question. So this is gonna be V, it's gonna be V, and I is the current, and R is the resistance, right? So if you make the changes, I will be basically 110 over R, that's it. So we just change the V with 110 because that 110 stands for the volt. Volt is V here. You see, volt is V. So this is gonna be our function. It's just like that. We don't have x and y, right? So just consider it is like y is equal to 110 over x. So here R will be like x, y will be like I. Alright, so if you say this way, it's more mathematical. This is more physics, of course. Since the question, how the features are here, it's asking, we'll answer them based on R and I. But one more time, R is associated with X and the I is with the Y. So basically this is going to be for domain, this is going to be for range. If you think of the graph, this time let's make it faster. Here you know, this is just like 1 over x, right? But we have 1 under 10. If it was 1 over x, remember the very first slide how we have the butterfly? It's just like that. It's gonna be exactly the same graph because we don't have numbers around it, as you can see. It's just gonna be that. But this time I can tell the difference with this and 1 over x is just that the branches, you see these two branches, are a little bit more separated than each other. So basically the more number here you see, the more separated of the branches there are. Let's say if it is 1 over x, 2 over x, 3 over x, 4 over x, each time you increase that number on top, the branches will be separated more and more. Okay, so I can tell that's the only difference between the very parent function 1 over x. So easily we can tell what's the domain here, right? So remember, it's all real numbers again. All real numbers. You can show this anyway if you want internal notation, if you want to use the algebraic way, or just say this: all real numbers except what makes the denominator equal to 0. You can tell the vertical asymptote is here is 0, right? So since it is that, all real numbers except 0. That's the domain. Intercepts. Look at the graph. Let's talk about the x-intercept. I mean the range, we forgot, sorry. The range will be again same, all real numbers other than 0, because if you look at the graph, we have the line here, the horizontal line here, but the function never crosses that. So the range is also all real numbers except 0. Same. Intercepts. Look at that. The right branch. It never crosses the y-axis. Never crosses the x-axis. Same thing for this part, right? So intercepts for both we will say none, because it never crosses x and y-axis here, so we don't have them. Does it mean that we will never have x-intercepts? Of course not. You can just tell it from the previous example. We got the x and y intercepts. It's basically whether it's shifted to the left, right, or up and down. For example, if you shift this function a little bit up, it will surely cross the x-axis, so we will have 1. Alright, so the function is always positive when it's above x-axis, right? So here it is positive, here it's negative. So positive when x is greater than 0, that's how it is here. Or basically the when y is greater than 0 is of course negative when is y, which is I in this case, less than 0. So these are the important things so far: domain, range, intercepts. Positive and negativeness is not that much, you can just think about that, but domain, range, and intercepts are important. Symmetry. I can tell we have kind of like a mirror, a small mirror at the origin that this function is reflected over, right? So this is symmetric over origin. You can say so, origin symmetric. Okay. And behavior is the last thing we will discuss in this question. Look at that. When x goes to infinity, or the other way to say, r goes to infinity, you see where is this function going to? It gets close to the x-axis but never crosses, right? So basically, since it doesn't cross that, we will have the 0 that's approaching to. When r goes to positive infinity, I goes to 0. I is basically y. It goes to 0. Or same thing, when r goes to negative infinity, maybe I should say this is r and I instead of x and y. Yeah. So r goes to negative infinity, as just like here, you see the function is also getting close to 0 on the y-axis, on the I-axis. So we will say it's gonna be I is approaching to 0, right? Just like that. So end behavior is that. End behavior is the other way is, guys, we can tell it's associated with the horizontal asymptote. You can tell that, right? Look at this. X-axis here, y-axis here. So it's associated with that. So by the way, there are questions, after each question that we are solving, right? So I will give the answers of these at the end, but please, when you are gonna when you go over these lessons again, I want you to do the check questions again, and I will give the answers of these at the end of this video, that what are the answers for the check questions. Okay, so example 3 was on page 469. It continues on page 470. Again, there is a table. I skipped the tables. You know how to fill the tables. You plug the numbers, basically what are given to you, and use those numbers when they are necessary to graph the given thing. Okay, so that's the first part of the lesson. I can tell this is the first objective: how to find vertical, horizontal asymptotes, domain and range, and graph the basic functions here. So here, part 2. So before we start part 2, if things are confusing, I want you to go over the lesson again and see what happens. So the second part is a more complex. On the second part, we will talk about again the same: domain, range, horizontal asymptotes, vertical, and here also the transformations. When we learn about the function, we talk about the transformations, right? Like how we did in exponential functions and logarithmic functions. Same thing in the rational functions. And if you remember that AHK template for the other type of functions, this time we have this one for the rational reciprocal functions: a over x minus h plus k. AHK are numbers, and they're important numbers. H is associated with the horizontal asymptote, where the function goes left and right. If h is something positive that you have here, that means you go right, you shift that right. If it is negative, you go left. K, if it is positive, you go up. If it is negative, you go down. That's basically what it is. Just like the other type of functions. Okay, so to understand what they look like, I suggest you to go to Desmos, or if you downloaded the graph calculator I suggested to you, the CX calculator that we used in the classroom, use that and just plug some random numbers and see how they are shifted to the left and right and up. So basically that's what it is. K is more than 0, K is less than 0. Okay, and A, if A is a number more than 1, remember we said it's a stretch vertically. If that number is between 0 and 1, it's compressed vertically. That's the thing. You can imagine that we are talking about the positive A's. If A is also something negative, that's a reflection over x-axis. Reflection over x-axis, you can say that. If you don't have negative, like -2 here, you don't have a negative sign here, that means no reflection. You'll just talk about stretch or compression. So basically, stretch is what? You know how we have the graphs? This is our graph, right? This one. If that A is bigger and bigger, you know what? It's gonna be, again, the branches will be far away from each other more and more. Like that, But if it's a number between 0 and 1, it's gonna be compressed. That means they are getting close to each other. The branches will be close to each other. That's the deal. Example 4. Graph a transformation. Graph a transformation of a reciprocal function. So this is on question 471. So before that, as you can see, we have to define what are A, H, K, always. A is, as you can see, it's -4. H is, be careful, it's not just 1, just like the other functions. If you remember the template, like the formula, it has to be a negative here that you have to modify. So +1 is actually a -1. So that makes your H is -1. And K is just whatever it's negative or positive. Since it's -2, that's -2 here. But always be careful with the H, just like the other type of functions. Okay, so I'm gonna read the sentence here on the page 471. The graph is reflected, I'm talking about this, the graph is reflected in the x-axis because of negative sign and stretched vertically. So what you will write there is gonna be x-axis. And the h is -1. It says the graph is shifted 1 unit left. 1 unit left. Because of -1. If it is negative, h is negative. Or if you have positive here, that you can directly say it is shifted 1 unit left. And k is -2 makes it 2 units down. Right? So, one more time. The parent function is 1 over x. This is vertical stretched. First, this is vertical stretched. And reflected over x-axis. So it become a -4 over x. Then we shifted it 1 unit left. That become -4 over x plus 1. And 2 units down. So finally -4 over x plus 1 minus 2. Which is gonna be the graph of this one, the green one. The f of x is the parent function. It's reflected, so we got this one. Okay, domain and range is the part that we have to answer. Domain, look at the x-axis. For this green function, we have the green function, right? It looks like covers everything, but except it gets close to a number, which is gonna be this line. Remember we said that this is the vertical asymptote here. Sorry for my drawing again. So it's gonna be -1 here. And if you look closely, you will see the horizontal asymptote will be just passing through this way, and y is equal to -2. The other way to say, remember, what is this number here? Let's use different color. -2. That is this horizontal asymptote. What makes this one equal to 0? That's -1, right? It's gonna be the vertical asymptote. Remember how we had that before in example 2, I guess. Alright. So basically, domain will be all those numbers but except -1, because we know that the green function never crosses the x equal to -1. So say it, all real numbers except -1 itself. Same thing here, range. We have the y-axis, all numbers are fine but except -2, because the function, the green function, goes away from -2, never crosses -2. So all real numbers except -2. One more time. -1 was your vertical asymptote, -2 was your horizontal asymptote. Basically, horizontal asymptote is not gonna be part of the range, and the vertical asymptote is not gonna be part of the domain. So that's the deal. The graph is the green one, and the domain and range is this one. And here's the transformation. Let's go to the ultimate level. Example 5 here, yes. 4 is here, 5 is here. This time, this is just like example 4, but the opposite way. This time they give you the graph, they give you even a point, a specific point on the function, which is right here. And they want you to find the asymptotes and the AHK. So then finally answer what's the graph. Like what specific function is that? G of x is what? Based on given function. So very easy. Let's start with A, HK. We need to find these out first. H, right? You can tell what's H and K directly, but you cannot tell what's A. For A, we will find a different way. We will use a different way. For H, remember, this is the vertical asymptote. And K is about the horizontal asymptote, right? So let's look at the vertical and the horizontal asymptotes here. Let's start with the vertical one. I can tell this graph, the branches are getting close to this number here, right? And same thing of this one. So looks like we have the vertical asymptote at right here, right? Can I say it is -4? You know how it's like passing through -4? So x is gonna be -4 is gonna be our vertical asymptote. Horizontal asymptote here is gonna be y is equal to -2 right here, because I can tell the curves are like getting close to -2 and -2 here in these two branches. So the horizontal asymptote is gonna be -2, so h will be -2, and the vertical asymptote will be -4, so k will be -4. There we go. So we can basically plug them here. So g of x is gonna be a over x minus -2 minus 4, like this one. If we fix it, it will be just a g of x is a over x plus 2 minus 4. This is what we have so far. H is -2, k is -4, and we got a over x plus 2 minus 4 here. So let's answer what we have so far. The asymptotes, we said that, right? That's x is equal to -2. And this is the, I'm sorry, this is the other way. X is equal to -4 is the vertical asymptote, y is equal to -2 is the horizontal asymptote here, like that, right? So h is negative the other way. Okay, there's a little mistake here, so we just put the things like wrong way, sorry for that. So h is -4, k is just -2, yeah, because vertical asymptote, because horizontal asymptote, yeah, this is better. So x is equal to -4, so here h is equal to -4, yeah, y is equal to -2, k is equal to -2, right? There we go. Okay, horizontal and vertical asymptotes told us about h and k. Now we have the function in this way. Since we are looking for what's a, we are going to use a specific point that's given on the function. You see that -3 and 3. This is a point that will tell us how to find the a. So I'm just copying this one onto the next page to find a. Basically, we will just do math to find that. Remember, the function we had so far is g of x was equal to a over x minus -4, right? And -2. So far we had that, and we know that -3 and 3. Was it -3 and 3? Yeah, that's -3 and 3. That's the function that we have on the function. By the way, sorry, this is also needs to be changed. X minus -4, and this one right here, that's just gonna be -2. This is better, yeah. Okay, so here we go. This is the correct version, of course. So -3 is the x, as you can tell, and 3 is the y. So we will have a 3 for the g of x. Remember, g of x also represented by y. So 3 over a over, since x is negative 3, I will have a negative 3 minus negative 4 here. And plus negative 2, but I would like to say it's just negative 2 like that, right? And if you do the math, that's a 1, right? So basic math, 3 over 3 is equal to a over 1 minus 2. Add the 2 to both sides, you will get a is equal to just 5. Remember how we had h and k? They were negative 4 and negative 2. If you put all these back to the template, that a is 5, h is negative 4, k is negative 2, that will be a 5 over x minus negative 4. The other way to say x plus 4, that's better, x plus 4. And minus 2 will be our graph. A is 5, h is negative 4, and k is negative 2. Alright. So that's basically what it is. It takes a lot of time, I know, but please go over this video and please follow the, fill the lecture part starting from page 469 to 472. And I'm also giving you the answers for the check questions. So the first check question on page 468. The check question on page 468. The answers are x is equal to 0, x is equal to 11, x is equal to negative 4. The check question on page 469. The vertical asymptote is 0, horizontal asymptote is 1, domain is x is other than 0, range is g of x is other than 1, x-intercept is negative 3, y-intercept is none. That's the answer for the second check question. That was on page 469. Example 3, the check 3, page 470. The check question. Domain is x is other than 0, range is y is other than 0, x-intercept is none, y-intercept is none, function is positive when x is greater than 0, negative when x is less than 0, and behavior when x is approaching the negative infinity, y is approaching the 0, when x is approaching the positive infinity, y is approaching to 0. And given the context of the situation, the domain is limited to positive integers only. Okay, let's look at the check question. For example, for the answer that's on page 472. The answer is domain is x is other than 1, range is other than 3, y is other than 3. That's what it is. And the very last check question, the answer, page 472 again. A is negative 6, h is negative 1, k is 2. Basically, remember, h is the horizontal asymptote, k is the h is the vertical asymptote, k is the horizontal asymptote. And when you put these on the function, that's negative 6 over x plus 1 plus 2. The function is negative 6 over x plus 1 plus 2. Alright, so that's the end of class. Please let me know if you have any question. I know the first lesson was a little bit like, we are getting used to it, so I believe it's going to be much better in the next ones. This lesson is a little bit tougher, so go over the lesson carefully. Watch the Khan Academy videos. It's going to help you a lot. Alright, take care everybody.